Hello, everybody. I think we're live. My name is Rosalind Craven, and I lead the private networks research at STL Partners, a telecoms and tech specialist consulting and research firm. And most importantly, I'm going to be moderating this next panel session. The topic for this session is From Cloud to Edge, deploying agentic AI for autonomous industrial networks and operations. And inherent within that title are actually quite a lot of different questions and topics that we're going to be hoping to kind of address and illuminate on during the session. Obviously, from cloud to edge, we're asking a question there. Do we want cloud? Do we want edge? When do we want each one? Why do we want them? Um, but also talking about deploying agentic AI, um, we're going to be looking at, well, how is agentic AI beneficial and impactful both for helping deploy autonomous networks in industrial settings, but then also helping to enable automated industrial operations, and then how do the networks again kind of get involved there. So there's many facets to this discussion, and we've got a really wonderful, well-rounded panel to help us discuss them. We've got two experts who have lots of experience in working with agentic AI and deploying AI in industrial settings. Using networks to help make that work. We also have an expert from a vendor with a lot of experience in deploying the networks that are then going to be working with that agentic AI. And we have an agentic AI specialist who's working on a Europe-wide project to help bring the benefits of agentic AI into industrial settings. So I'm going to ask them to introduce themselves. I'm going to start with the first three, asking them each to introduce themselves and their role and company, and also to give an example of a real life occurrence where they've seen agentic AI bringing benefits in an industrial setting. Let's start with Jason.
Excellent. Rosalind, thank you for having me here today. And it's just an exciting opportunity to get to speak with everybody today about some of our use cases there. I'm Jason Wallen. I'm the Senior Principal Architect for Tech Stack at John Deere, which is just a fancy way of saying that I have responsibility for things that run inside the factory, inside the cloud, and inside our data centers. But I also represent today the 5G OT Alliance, which is a bunch of discrete manufacturers that build things and use the private networks that they have to be able to support their manufacturing operations. And one of the examples that I'd like to highlight for you today that we use is when we take multiple different streams of data and are able to use AI to be able to analyze the quality inside there. Also focus on predictive maintenance and process optimization for how we do manufacturing. One example I'll give you is around weld quality. So with the industrial IoT, we can monitor the voltage, the amperage, and the amount of wire that is fed into a particular weld. On top of that, we can use computer vision to actually take a measurement of the weld that is laid down in the facility, and then use acoustical monitoring to listen to that weld as it's being laid down as well. So that'll give us 3 different data streams about the quality of that data, and then use the inferencing inside AI to be able to support the decision of, was that a good weld that was laid down? Is that something that we can continue to do, or do we need to change our manufacturing processes to do that? And by doing that, that's where the private cellular networks become very, very critical to be able to transmit all that data quickly, make that inference at the edge, and then be able to store that data longer term for deeper analysis when we need to do some deeper analysis in the cloud as well. So to answer that question, we do a lot of that inference at the edge if it's a real near-term decision that we need to make. And then for longer term, we store that in the cloud and then can do analytical data that allows us to compare factory to factory, as well as business optimization process and opportunities too.
Thank you, Jason. I'm going to ask Mike now to give the same type of introduction.
So thank you very much. It's a pleasure to be here. And how I ended up in artificial intelligence it just kind of landed on me, I guess, by asking a simple question: why can't you beat Amazon? And it turns out the answer to that question, when you look at where I come from, and I'm recently retired from Georgia Pacific, and now a research fellow at LNS Research. And that question, when you look at most of industry today, says that most of our data is not in great shape. It's difficult to connect, and that if you're going to be really good at this, it turns out predictive analytics for most of the industrial world not really reliably predictive, and that once you get a prediction from it, the capability of the organization, because it wasn't built around that, to do something with it is not really effective on the backside. So you get something that's about a quarter effective. And so how do you go solve for that? And so turns out agentic AI is one of those things. And agentic AI is built around what we would call the human agency model. And so what we did was we used Judeo-Pearl's principles, which is built around the human agency model, and we modeled a supply chain based on how one should operate, which is how do you understand the world? What are the interventions you can take relative to the counterfactuals in that understanding? And then how do you take and evaluate the evidence and feed that back and reinforce that learning to optimize end-to-end in a supply chain by teaching it all the variables from the way you supply to the way you make paper. And you can actually reduce all that complexity in an entire supply chain through teaching all the various functions and processes through agentic AI, and take all the complexity out and end up trying and achieve an outcome. And what you'll figure out is that embedded loss of optimization is about 20% in most enterprises. And that in itself is where the value comes from.
Fantastic. And now, Puneet, please introduce yourself, your company, and a real life example of agentic AI bringing benefits that you've seen.
Thank you, Rosalind, and thank you for the opportunity to be among this team panel. And hello to everyone, all the attendees. I'm Puneet, head of product and field engineering here at Salona. At Salona, we have been over the last 6.5, 7 years building an enterprise-focused private 5G infrastructure to enable folks like Jason and Michael to run their mission-critical industrial operations. My background spans enterprise networking, AI ops, and wireless systems. And to kind of think about examples as a vendor, I think we approach AI automation in two ways. One is networking for AI and AI for networking. So let me kind of give two quick examples. Networking for AI, not very dissimilar from what Jason was describing. A recent example that comes to my mind is a manufacturing customer that is using AI and computer vision for predictive quality and maintenance. Their agents are continuously observing production lines through computer vision and IoT telemetry. And when an anomaly is detected, such as vibration patterns from a motor changes subtly, the agent can then automatically adjust operational parameters, or if needed, trigger a workflow through ServiceNow to then dispatch a maintenance. So, and they need a private 5G network to ensure deterministic latency and reliability. And that's where we kind of come in. The second portion of it, AI for networking. So at Salona, we also have an example of Salona Orion, which is a home-built agentic AI platform that we have built. And Orion is designed to make private 5G network operations as autonomous as possible. And the big goal there is to continuously monitor how devices are doing, what the experience is, how the devices are interacting with applications, and looking at all of these KPIs, learn from those patterns, and then act on that data. So for example, if a new device comes on the network and the workload shifts, Orion can automatically allocate spectrum, adjust QoS, and in some cases, isolate an issue that could be impacting the performance. So I would say those are kind of the two goals, targeting networking for AI and AI for networking, that we see on a regular basis.
And finally, I'm going to ask my last panelist to introduce himself slightly differently because of the different context in which he works. So, Raffaele, please introduce yourself and your organization and the benefits of agentic, the benefits that your project is working towards bringing to industries.
Hi, everyone, and thanks for the invitation in this panel. I am Raffaele Cestari, and I work for Reply, that is an Italian company with 16,000 employees worldwide, and it is essentially a consultant company in the information technology area. And let's say that I have a PhD in information technology, so I think this is a quite good match. And particularly, I studied and I worked on developing time series forecasting algorithms and also classification algorithms in the research context in different areas. And then now I am working as an AI specialist in Reply with the focus of a European project that aims to develop an orchestrator for telco networks. This is a very huge problem, a huge topic. And when we talk about AI, we must be, let's say, at the same time, specific and general. Specific because with AI, we might mean many different areas which span, for example, from optimization, then machine learning, that is, let's say, the first branch that emerged in the last years, and then generative AI. So the idea here in this project is to use each technology in the specific context where it most fits in order to exploit and achieve the best performance and the task we aim to solve. Some examples might be optimal resource management that at the same time considers network resources, so bandwidth, reduce latency, for example, but also we want to optimize the energy consumption. So is the network sustainable? So in all these aspects, AI as optimization takes place. And for sure, for what concerns generative AI, we would like to allow the user participating in this platform to have the smoothest experience that he can achieve. And let's say this is a brief overview of the project. And as it is guided and driven by the European Union, the goal is not only to provide a platform that is helpful for companies and to, let's say, workers in the telco sectors, but to each citizen of the European Union.
Thank you. So with those instructions and those multiple examples of the benefits that generative AI can provide in this kind of context, I feel, we've established that there's a lot that agentic AI can do for industrial enterprises. So now I want us to talk a bit more about what it needs to make it work in terms of connectivity, architecture, what is the most important. And I am going to pick on Mike to go first.
So I think the most important thing probably is not the technology, because the technology exists, right? The most important thing is actually us and how we start to frame, how we apply the technology relative to the problem we're going to solve. And so if you take a position that says reasoning at the edge is actually going to happen, which it will, reasoning at the edge will become a thing, right? And so now that reasoning happens where all the context is, because that's where you're going to need it, then ask yourself the next question. How do I make reasoning at the edge take the maximum effect for me? And that reasoning at the edge requires ubiquitous connectivity. In order for you to drive decision velocity, because latency inside the enterprise is the largest tax you pay that never shows up on the balance sheet. And so when you look at enterprise, what happens is that information goes up, decisions come down. Most of the information exists in the enterprise. The problem is that the walls are there, they're transparent, but the actual what the information is opaque because it's trapped behind all this gated architecture that we call a structure of an organization, right? So in order for us to get at that and allow this 1 degree of separation to actually exist from an enterprise perspective, which is reasoning at the edge, we have to have ubiquitous connectivity that allows the architecture of permission and trust to really exist. And that architecture says that I trust my agent, which is working on my behalf, trying to shape the outcome that I want, and to exercise a workflow for me through this in order to take advantage of the connectivity I have in order to create competitive advantage because I have the connectivity and can generate the decision velocity that allows me to use my access to what the customer needs in order to drive an outcome, right? That's the architecture that matters instead of having an organization that's built through all these gates that says that I have to gate every permission because I only trust a human to make the decision. And managing complexity through a machine that's built to do that, where the guardrails exist to allow us to set its intent, that's the problem we're really solving, right? We're taking advantage of ubiquitous connectivity. We're allowing reasoning at the edge to drive and do the complexity for us, and then using the architecture of permission and trust to manage how that reasoning actually functions.
It's interesting that you bring up AI guardrails because one of the questions that's already appeared on the in the Ask the Speaker section was about that. I'm going to turn to Puneet now to ask you a bit about your take on what is needed to make to allow agentic AI to bring these benefits to industries and enterprises.
Sure. And again, just given that we are a private 5G vendor, I wholeheartedly agree with a lot of things that Michael mentioned. And maybe I'll cite an example in terms of how connectivity, as Michael mentioned, as being a critical portion of it, is usually an afterthought. We've had instances where some of our customers, eventual customers, when they started deploying these applications and invested heavily in AI-based applications, assuming that the connectivity is there and the reliable connectivity is there. So the investment happened on the application, investment happened on the compute infrastructure to run those applications. But then when they actually started deploying these applications, they could not really take advantage of all of their investments that had actually already happened. And what they found out was, in some cases, they had their associates in these really large oil and gas refineries with tablets that could now connect to back-end applications. But hey, when these guys are walking around with tablets in these large refineries, which are probably 400 to 500 football fields big, there is no connectivity there. So those things just become things that they carry, and eventually the only way they can upload data is get back to their office where there is connectivity and upload data. So where they needed connectivity, they did not have it. And in some other cases, another example of a manufacturing customer who had their existing wired and wireless infrastructure, but the AI applications that they were deploying required a certain level of reliability and latency that their current networks were not able to deliver because they were probably oversubscribed or were never designed for that. So as I said earlier, connectivity often becomes an afterthought. But for AI applications and all these investments in AI to really come to fruition, I think reliable, low latency and deterministic connectivity is absolutely non-negotiable. Agentic systems often need this observe, act, learn loops, and this has to happen in real time. So technologies like private 5G networks are going to be foundational in this. But in addition to connectivity, I think the other part which is critical, which also becomes a bit of an afterthought, is uh, actually getting data from these legacy systems on which they might be deploying these AI applications. So data integrations with OT systems, which have a really long life cycle. How do you get that data integrated with these OT systems, with IoT sensors, and these digital twins? Because at the end of the day, situational awareness is going to be very, very important. Context is going to be very, very important for these AI investments to bear fruit. And I think those are probably two key things that come to my mind: connectivity and the ability for data integration with these legacy systems.
Sorry, I was just scanning the questions, but I want to come to Raffaele as an AI expert, and and someone who's working on a platform to enable more enterprises to take advantage of agentic AI. What are the important factors apart from potentially having a useful platform to enable those use cases to be spun up? What are the important factors that need to be in place for agentic AI to work and bring benefits to enterprises?
Yeah, let's say that linking the answer to the architectural point of view, AI, let's say, can be also used in a recursive way, in the sense that I can design algorithms that can help me in understanding where is the optimal place where deploying algorithms. So it's like a recursive approach to this framework. So I have a lot of data. I have a platform that must accomplish defined tasks. One strategy that we are considering is, let's say, to let us be guided by AI in order to understand where the AI itself can be most beneficial. And this leads us to the concept of exploiting each algorithm really where it best fits. So let's say, to be more specific, we can, for example, consider the idea of having some layers in which each layer is optimized, and the output of a layer is itself an optimal solution that will be given as input to the lower layer. In this sense, each layer is optimal for itself, but also the overall architecture will be optimal as a connection of optimal components. That's the idea. I hope that it was clear enough.
Yes, thank you. And Jason, do you have anything to add? I was going to say another kind of flipped around way to consider this question is like, what potentially are the barriers to more uptake of these types of agentic AI solutions? What's going to stop them from working?
No, that's an excellent question. Really, really appreciate that. And again, it's really coming down and focusing on that business value that you're trying to deliver, right? Technology for the sake of technology is cool. And it is neat to talk about the speeds and feeds of that, but really understanding that business value that you're trying to extract from the process, whether that be connectivity to help with preventative maintenance, connectivity to be able to help with quality assurance, mistake proofing, or process improvement around the engineering. And then foundationally, there's three layers that's built on. First of all is data quality, right? We've heard that from some of the other panelists here. But at the end of the day, if you start a agentic AI or even a generative AI journey on top of questionable data, you're going to get questionable results to come from that. And you're going to get no better than that. So having that clean data in an accessible data lake that provides the ability for you to make that RAG request inside there. Really, the other part that can be problematic for this to be able to be delivered to is focusing on the compute layer above the data layer, and that is where you're going to run your actual inferencing models and then the LLMs that are needed to be able to complete that as well. There are lots of use cases that you can use the publicly available or cloud-hosted models for inferencing there, but when they are tight tolerances in wanting to make constant tuning and changing inside your manufacturing operations for that, a lot of that processing will need to move very close to the edge and be able to do that. Many of the use cases that we see today are still compute bound. So your biggest weight that you have is the actual processing time as those run through the RAG models that we're working on, and being able to do that. But also another piece that's clearly been articulated here too is the network connectivity that you have. Being able to have deterministic cellular-based networking inside factories really is a key for those very tight tolerance use cases that you have using AI to be able to deliver that value immediately back to the stakeholders on the shop floor as well.
I mean, this has very much brought us round to another one of our key questions, which is inherent in the topic, which is, edge versus cloud. Like, how do we decide which workloads to run where, and, what are the important factors to think about? We've touched on some of them already. Performance, I think, performance in that demand for quick decisioning and lower latency being clearly one of them. But what about other factors like cost or security? How do we make these decisions? Anybody can jump in.
I think this is going to have to be something we have to learn our way through, and we haven't lived this world, and so like everything else, as we become more familiar with what it takes to do some of this stuff relative to what it is you're trying to achieve, that will solve itself. It's kind of like saying to yourself, in the new world, do you realize that the agentic world software is disposable? Not many people realize software is disposable in the agentic world. What it needs, it writes and disposes it when it's no longer relative to the context anymore. And that is a mindset shift that people just can't get past. What that actually says is the architecture matters more than the software, right? And so that architecture is where the security is now. So that's how we have to start to think, is when these things are really true, how does that make us think about what the world becomes?
Yeah, I think it comes down to, I guess, again, there's not one size fits all, but I would say it comes down to the specific use cases, and it's not one or the other. I think that from a compute perspective, you probably will have to look at a distributed architecture. Latency, as you said, as a lot of folks said, is going to be a key factor, given that you need to be making these sub-second decisions. So if that is a criteria, then edge is probably the only viable option for those models to be running. I think liability, data sovereignty, I think that becomes a key piece as well, especially for sensitive and regulated data. The edge processing might be the only option, no matter where. Cost might be a secondary factor there, and you probably have to run it at the edge because the regulations require you to do so. So I would say that the cloud continues to be, or will continue to be, invaluable when it comes to training models, when it comes to global coordination across multiple sites, and doing analytics at scale. But real-time intelligence layer will increasingly depend upon all of these models kind of living at the edge. So I think we'll see a combination of the two.
And Raffaele, I expect that those topics that Puneet has touched on of data security and data privacy are a big, certainly something that you have to focus on when, designing your platform, bearing in mind that it's based in Europe, where the requirements for, for security and sovereignty are quite high.
Yeah, let's say that just to start, we have technical debt in the sense that there are not many European companies with relevant weight in the, let's say, data domain. So what we must do is to drive our companies that have permeation within the territories that are typically telco companies to exploit their own resources in order to bring up data centers that intrinsically are edge, because typically these kind of companies have resources locally in the biggest European cities. And given this, let's say, geographical point, we also have the fact that we must protect data, because each datum is mapped with some real life activity with people, and so data must be for sure anonymized in order to prevent any, let's say, link between a physical person with that data if there is data leakage, for example. And the question is, where do we want to store these data? If we store them in a centralized manner, we have to protect, let's say, just one place, just one set of servers. But at the same time, if we have some issues with that physical place, then we might lose our data, or let's say our data might be affected. On the other hand, let's say we can store the data in a federated way. So we do not store all the data in the same place, but we keep it, let's say, limited to the specific area where the data was generated. And let's say the problem here is that we must transfer data in order to, let's say, design solutions that consider all together all the data that we have locally. And when we transfer data, we have other problems. So we must encrypt data and ensure that at least we have end-to-end encryption. And so, let's say, that is a focal point, and our resources are really invested in order to achieve these high standards, because without these standards we cannot have any solution that is based on AI. So let's say everything else is becomes useless.
I have so many other questions that I could ask you, but I'm going to switch to bringing in some of the Ask the Speaker questions from the audience. So there's one question to the whole panel. Given that agentic AI generates specific outcomes, have you seen any examples where the agent can poll APIs and independently learn what data is available from the Edge app payload? And there is a follow-up question, which I'll give you both and then give you a chance to mull the first question. The follow-up question is, do you have any examples of agentic AIs strung together? In other words, each agent has a specific task, and once completed, the output is handed over to one of the many other agents, so multi-agent systems. Would anybody like to have any comments or would like to address this question?
So the answer is yes to that. And so the big issue with this is orchestration. And so there's several companies. If you look, you can kind of break AI down into first generation artificial intelligence that is largely just data centric, right? And you got to build massive amounts of data, massive amounts of variables. and massive amounts of power. And then along comes causal, and what causal says is that, hey, only these variables matter, and I only need to look at this data in order to determine what an outcome I'm trying to shape, what matters among those variables in that data. And out of that, you build a knowledge model that says, I'm looking at these variables in this data, and I only need to remember the data that's different from the knowledge model I have. So not everything matters, and you ignore it, and then you're just trying to optimize to some future state. And there are companies out there that are doing this today, and they're the most advanced companies when it comes to artificial intelligence because they apply causal in that way. We did this at Georgia Pacific. There are other companies doing that. There are petroleum companies doing that. And if you think that causal is deterministic, it's not, right? It's not, because of the temporal effect of the way you make decisions and the externalities that are involved. And so when you think about this stuff, you have to understand that you're in this world that works that way. Now, the second generation artificial intelligence that comes has the ability to take into account all of causal and then write back on its own self software that adapts to the world around it, these APIs, and that stuff is just starting to exist.
Mm. Any other comments on that question? Because I do have another. We've got 2.5 more minutes of this session. There's another question here. Edge AI servers have highly variable power draws depending on inference load. Does agentic AI have a role to address this dynamic variability in power draw for edge AI compute nodes?
So I'll take a swing at that one there. I think that power consumption on the edge is going to be very similar to what we see about other infrastructure optimization opportunities that we have on the use case there. I know our friends from Solana who are on the phone here have done quite a bit of work around optimization of the private 5G network, just based on the level of observation that they see about that. We also think about that in the manufacturing environment beyond just the network, but what are the other attributes and feeds that come in and become available for us to be able to study that. And we think about either network or infrastructure outages that we've seen in the past now become an opportunity for us to use AI to do that first level of triage, be able to do that first level of troubleshooting. And by doing that, our network operators and our infrastructure engineers are able to come in and not be able to be given an update as to where they're at with what do we believe probably the 2 or 3 most likely opportunities are for either optimization or incident reduction inside there. And a similar pattern could be very easily supplied around where do we start to run these workloads when we're dynamically creating code or vibe coding type solutions that are able to do that, trying to figure out, today it seems like these need to be done at the edge, and we'll be able to do those type of cases that'll evaluate that patterns change of usage, and then it's determined that they can be run more cost effectively in the cloud, being able to optimize those workflows just as we optimize infrastructure troubleshooting and management today as well.
I think Jason's right, because when you look at some of these automotive manufacturing companies that are trying to go to more electric vehicles, they're actually moving these knowledge models to the edge on their sensors, right, instead of these heavy data models.
We have officially 10 seconds left in our allotted time. I'm sorry to all the questioners whose questions I haven't got to, but I'd like to take this opportunity to thank all the panelists. I think that was a really interesting and informative session, and I hope you will enjoy the rest of the event. Thank you very much.
Thank you. Bye-bye.